Continuing our review of exponents, we're going to talk about our power property. So the property itself says to find a power of a power, you're going to keep the base and multiply the exponents. So when we are doing power of a power, you are going to multiply the exponents. There we go. We're going to look at a couple of examples. Actually, first let's look at the property itself. So the property itself says if I have a to the m to the n, that's going to be a to the m times n. You're going to keep the base and multiply the exponents. Now let's look at a couple of examples. Here I have x to the third to the fourth. That's power of a power. So I've got an exponent raised to another exponent. So I'm going to do 3 times 4 is 12. This is why. This is how come that works. X cubed to the fourth means to do x cubed times x cubed times x cubed times x cubed. And then once it's multiplication, you keep the base and add your exponents. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So we're using that repetitive multiplication, which is what an exponent is, to validate this property here. When you have power of a power, you multiply your exponents. It works if your exponents are negative as well. So here I've got power of a power, so I'm going to keep the base, and then negative 5 times negative 2 is a positive 10. So keep the base, multiply the exponents. If you have more than one part of the monomial, this only works with monomials. As soon as you put a binomial or trinomial, this doesn't work. But if you have a monomial, one term right there, you will do each term or each piece raised to that exponent. So this would be 2 to the third, and then x squared to the third. I'm going to do 2 times 3 is 6. And then y to the negative 1 to the third is y to the negative 3. Now, two things I want to do here. The first thing I want to do is that 2 to the third. 2 times 2 is 4, times 2 is 8. That x to the sixth. We typically don't like our negative exponents, so I'm going to go ahead and drop that to the denominator and make the exponent positive. So we had a couple of things going on in that one little problem there. I'm going to show the whole page. Pause if you need to, and then we have just one other quick thing to talk about. And this video will be done. So pause here if you need any piece of this. We want to make sure that we are using the correct properties. So I've got two different problems here, x squared times x to the third, and then x squared to the third. This first one is going to be my product property, or my multiplication. And it's my multiplication because they each have a base. It's x squared times x to the third. So here I'm going to keep the base and add the exponents. This one is my power of a power. Because it's x squared cubed. See the difference? X squared times x cubed. That's a multiplication problem. This one's x squared cubed, or x to the second to the third. So this one's power to a power, I'm going to multiply my exponents. You have to make sure that you're using your product or your multiplication property and your, boy, that's messy. That says multiplication. Your product or your multiplication property and your power of a power property at the right time. You're going to keep the base and add the exponent. When you're multiplying, you're going to keep the base and multiply the exponents when you have power of a power.